Hi, and welcome to the 35th session of Physics 9. This is Sir CJ, and in this session, we are going to be doing the following parts. The first one is under Gather Information Activity number 73, Rolling Down the Hill. And then the second part is still under Gather Information. It's a problem solving activity where we are going to have a sample problem on energy conservation. And then the last part of this session will be still under gather information, where you are going to be given your own problem which you will be solving independently. In this video lesson, we are still working on the mastery of the following learning competency, which is performing activities to demonstrate conservation of mechanical energy. And this is the code. You will be seeing the content of this session in the 7E based self-learning module in Science 9, which I wrote particularly in Unit 4, book number 22, pages 11 to 15. Let's begin. For the first part, activity rolling down the hill, activity number 73, the objective of this activity is for you to be capable of identifying forms of energy acting on an object. And then the next one is for you to be capable of explaining how gravitational potential energy, elastic potential energy, and kinetic energy transforms and gets conserved in a system. The materials you'll be using for this activity are the following: a piece of paper for your note-taking and an accompanying pencil or pen, and then a stack of books, some cylindrical kind of container. You could actually use an empty plastic water bottle or any cylindrical container you have, like a container for chips, a foot rule, a wooden board, or any plain object that can serve as a plank where the cylindrical container is going to roll down, masking tape for marking purposes, and then a stopwatch, which can actually come from your cell phones. The first step is you have to prepare a stack of books, and then you have to put one end of the plain wooden board on top of the topmost book, so ganito siya, while the other end sits on the ground or on the floor. For the second step, you have to mark the following points in the wooden board with a masking tape. So this is going to be marked as A, and then this is going to be B, and then a little beyond the 50% of the length of the plank, you can put C, and then right there near the end will be D. So yeah, you're gonna be using a masking tape in marking, and in labeling these points in the plank. For step number 3, you will be putting a cylindrical container in point A, and then you're going to release it. Record the distance it traveled after leaving the plank and the time it took for it to get there. Okay, so make sure that you are taking note of the distance it traveled after the plank. Okay, and then you record the distance that you recorded, that you got from the data from the experiment, as well as the time. You will be using the following format for the table. So for point A, how much distance and time did you gather, and then solve for its velocity. So you simply divide distance by time, and then put it at point B, and then record the distance and time and compute for the velocity. You put it at C, and then you record the distance and time, and then you compute for the velocity. And then put it at D, you record the distance and time, and then compute for the velocity. Make sure that your table is easy to understand. You have to make sure as well that you are following the current formatting of the table. You may start doing the activity. Are you done? Make sure that you already have your table. If you are done, then let's answer the guide questions. For the first guide question, at which point is the velocity lowest? And at which point is it highest? Now, why do you think this is so? Pause this video if you need more time. If you're through, let us proceed to the next guide question. For question number 2, what is the effect of height in the velocity of the cylindrical container that you used in this activity? So notice that the highest point in the activity was point A, and then the lowest point was point D. Pause this video if you need more time. If you're through, let us proceed with the answers to these guide questions. For question number 1, the velocity of the container of the cylinder was lowest at point D, while it is greatest at point A. This must be because of the difference in the gravitational potential energy of the cylinder when it was put in points A and D. If your answer is close to this one, you can consider it correct. For the next question, the answer is, with a greater height comes greater gravitational energy. Now, since the gravitational energy or gravitational potential energy at point A is higher than that in point D because of the difference in their heights, this translated into higher kinetic energy, thus a faster velocity when the cylinder was released. So, if your answer is close to this answer, you may consider that correct. So, how did you do? Okay. Now, through the activity, you found out that height or age of an object from the ground affects the velocity of the object once it drops or slides down. So, kapag mas mataas yung pinanggalingan ng isang object, mas mabilis siya, of course, na bababa, and it keeps on accelerating. While if it's just released from a relatively lower height, it's just gonna be traveling, at a slower speed. The greater the height, the greater the gravitational potential energy. And this huge amount of the gravitational potential energy is actually transformed into an equally great kinetic energy, as evidenced by the higher velocities from the cylindrical container as it gets upwards. So, yung sa point A, point B, ayan, dun may pinakamataas na gravitational potential energy. And as discussed by this slide, that translates into a greater kinetic energy as well. Okay, so now that you have an understanding of the concepts, let us put them mathematically. In the next part of this video lesson, let's consider the following problem. A 45 kilogram cart is 15 meters, so it's here, above the ground. If it drops to the lowest point, which is 5 meters, in the roller coaster track, what will be its speed upon reaching that particular lowest point? If its initial velocity was 25 meters per second. So it started here and it's gonna go there. Our concern is its speed at 5 meters. So the givens we have in this problem are the following. The mass of the cart, it was 45 kilograms. The initial velocity was 25 meters per second. The initial height was 15 meters. And the final height was 5 meters. Now, the constant that was not actually mentioned in the problem, but as you may know, exists in the problem, it's acceleration due to gravity, since the cart is bound to accelerate due to gravity in this instance. Now, it's equal to 9.8 meters per second. And then, of course, the unknown was the final velocity, which is now taken as the velocity of the cart upon reaching 5-meter point. The formula for this problem is as follows. The mass is going to be multiplied by v squared divided by 2. Actually, that's initial. And then it's going to be added to the mass multiplied by acceleration due to gravity. and the initial height. And then that must be equal to the mass multiplied by the velocity, the final velocity squared, divided by 2. And then it's going to be added to the mass multiplied by the acceleration due to gravity multiplied by the final height. So for all of these, the only thing unknown was actually VF. Now you have to substitute the given factors. So take your time. Using this formula, substitute the given factors. Are you done? Okay, if you're through, it's supposed to look like this. Okay, so in here, 45 kilograms is going to be multiplied by the square of 25 meters per second. That's going to be divided by 2. And then, in here naman, we're going to be multiplying 45 kilograms by 9.8 meters per second squared multiplied by 15 meters. So we're going to be getting kilogram meters squared, second squared over here. Here naman, we're going to be getting kilogram meters squared and then second squared. So they have the same kind of unit. In here, it's going to be a multiplication between 45 kilograms by final velocity, which is no longer written here, but it's supposed to be there, okay? So do not follow this mistake. And it's supposed to be squared, whatever the value will be. And then it's gonna be divided into 2. And then the next part is quite similar to the first one, except that this time the height is that's gonna be used is the final height, which is 5 meters. Okay, did you get this correctly? Okay, hope so. Now, we carry out the operation. So do every operation that I asked you to do or I described a while ago. Are you done? If you're through, let us now look at the following. So the result of the first set of operations will be 14,062.5 Newton meter, which is actually kilogram meters per meter squared per second squared. And then it's going to be added by the result of the second set of operations, which is 6,615 Newton meters, again kilogram meter squared second squared. And then that's going to be equated with 45 kilograms VF squared, which divided by 2, which couldn't be simplified in this case. It's going to be added to 2,205 Newton meters, again kilogram meters squared second squared. The next part of the operation is simplifying one side by adding them up because they have the same units naman. It's going to be resulting to 20,677.5 Newton meters, which is kilogram meter squared second squared. And it's going to be equated with the same old components of the other side of the equation. To simplify that further, what we do is we are going to subtract 2,205 Newton meters on both sides. We're doing subtraction because on one side and this side, it's an addition, so it's positive. We need to cancel it out, so we're gonna be subtracting. So you cancel it out, and you're left with this. So settling 20,677.5 Newton meters minus 2,205 Newton meters, which is going to result to 18,472.5. That's Newton meters or kilograms meters squared second squared. That's going to be equal to 45 kilograms VF squared divided by 2. Okay, so what do you think is going to happen next? Remember, this is a fraction now, and this is also a fraction. So what do? Okay, you're going to be cross multiplying. The word transfer here is more appropriately known in mathematics as transposition, but in my classes, I already told you that we don't do transposition. We actually do, multiplying, dividing, or adding, or subtracting in both sides of the equation. In this case, what we did was we multiply 2 both sides of the equation. So if you multiply 2 by 45 kilogram VF squared divided by 2, you're basically gonna be canceling them. So 2 over here, the whole number, and 2 over here is gonna be cancelled. On the other hand, the other side of the equation, you're simply gonna be multiplying 2 by 18,472.5 Newton meters or kilogram meter squared second squared, which is going to give you 36,945 Newton meters or, kilogram meter squared second squared. That's going to be equated to 45 kilogram VF squared. Now that it's at its parang simpler form, yes, what do you think is going to happen? We need to separate this yung VF squared from 45. What do we do? What do you think? Okay, do it. Are you done? Okay, so what we'll be doing is we'll be dividing both sides by 45 kilograms, therefore canceling 45 kilograms on one side. And you're gonna be left with VF squared in that side. Now dividing both sides by kilogram, you're just gonna be left with meter squared, second squared. And the absolute value of the number is gonna be 821 only, since you divided 36,945 by 45 over here. So again, this kilogram is cancelled because it's actually kilogram meter squared second squared. So we cancel kilogram, kilogram, you're left with meter squared second squared, which you will be equating to VF squared on the other side. It has squared, so remember that the reverse operation for squaring is getting the square root. Very good. So yeah, do the operation. Are you through? Okay, the final answer is gonna be 28.65 meters per second. That serves as the velocity of the cart upon reaching the 5-meter mark down the 15-meter mark. So ganyan siya kabilis. Okay, now that we were capable of answering this question together, I will now leave you to answer your own word problems. So yeah, grab your pencil and your paper, a piece of paper, and answer the following question. Now, since the cart is loaded with a passenger, the new mass of the cart is now 105 kilograms. So, una, 45 lang siya. Tapos ngayon may sumakay na. So, what do you think? What's gonna happen? What will be the velocity of the cart in the 5-meter mark if meron na siyang 105 kilograms worth of mass? And if it is launched with the same initial velocity na 25 meters per second from the height na the same lang, it's 15 meters per second. So, gaano siya kabilis ngayon upon reaching the 5-meter mark? Go ahead and start solving for this problem. You're basically gonna repeat everything we did in the previous problem, except this time we have a new given factor. Okay? Alright. Are you done? Cool. Now, the answer to this question is 28.65 meters per second. All right. Did you get it correctly? I hope so. Okay. Now, this ends this session. This, remember, is the 35th session of Physics 9. In this session, we were capable of finishing the following parts: gathering information on activity 73, rolling down the hill, and then we did a collaborative sample problem solving on energy conservation and transformation actually. And then we were capable of giving you an opportunity to test your own understanding of the process of solving problems on energy conservation through the last part. Remember that in this video lesson, we are training ourselves to be capable of performing activities to demonstrate the conservation of mechanical energy. Everything discussed here could be found in the 7E-based self-learning module in Science 9, particularly in Unit 4, Book number 22, pages 11 to 15. This is Sir CJ, and I hope that you are having a great day so far.